Hello students, in this session we are going to see some problems regarding the gyroscopic couple and the governors for speed controlling mechanisms. So already we have discussed about the gyroscopic effects in ship. When viewed from the rear end, it is called as stern, and the front end is called as bow, the left end is called as port, right side is called as starboard. So when the ship turns left, the stern moves down, which is mentioned in the diagram. So first problem we are going to see about the gyroscopic effect in ship. Given the mass of the turbine rotor is 2500 kg, the speed of the rotor is 3200 rpm, which moves in a counterclockwise direction when viewed from the stern aft side. The K value is 0.4 meters. Find the gyroscopic couple and the effect in if the ship turns left at a radius r is 80 meters and speed is 15 knots. 1 knot is 1860 miles per hour. So with the given values, substitute the value to find CG, gyroscopic couple, I omega omega p. So I value we know, omega value 2 pi n by 60, omega p is v by r. Substituting the values we give 12,988 Newton meter. After finding the values, draw a tabular column and mention the direction of rotation, direction of turn and the effect of gyroscopic couple. Similar problem for a gyroscopic effect in ship is given with the different values. Here we are asked to find the gyroscopic couple and the effect if the ship pitches 5 degrees. Pitching is given, which is 5 degrees above and below, and the pitching motion is simple harmonic, which is mentioned with the time period 40 seconds, and the maximum acceleration, maximum angular acceleration A max. So 5 value is 5 degree, change the degrees 5 into pi by 180, which is 0.873 radian. Given time period 40 seconds. To find omega naught, 2 pi by Tp. To omega p is 5 into omega naught, so the value is 0.0137 radian second. After substituting the values, mention the values in a tabular column. Similar problem, given mass of the turbine with the mass, speed of the rotor when viewed from the stern side. Find gyroscopic couple and effect for the angular velocity when viewed from the stern. Find C I omega omega p, and due to rolling, axis of spin and axis of rolling are same, therefore there will be no effect. So these are the 3 different types of problems in gyroscopic effect in ships. Next type of problem we get a gyroscopic effect when it turns at the radius of 75 meters and the speed is 100 kilometers per hour. Similarly, we know the formula C is equal to I omega omega p. Find I mk square value, omega 2 pi n by 60 and omega p v by r, and find the values, and the effect is given in the tabular column. So this is the next type of problem for gyroscopic effect in ship. Given mass m in 8000 kg, speed n 18,200 rpm, and the radius of gyration k value. Find gyroscopic couple and effect if the pitches as a total movement between extreme position as 10 degrees, that is 2 theta, and time period is given. We know formula when phi is given, 5 degrees is 5 into pi by 180 and Tp is 20 seconds, that is omega naught equal to 2 pi by Tp. Find the values, substitute the value I omega omega p. Similarly, we can solve this problem also. This is also similar problem. So these are some of the problems which are frequently asked in previous year question papers. So the value may differ and the names may differ, but the same problem type I is omega C is equal to I omega omega p, and we should know this tabular column. This is important. So next we are going to see about Porter Governor problem. Already we have discussed the specifications of Porter Governor. So problem of Porter Governor given: mass of the ball is 2.5 kg, mass of sleeve is 25 kg, and length of upper arm is given 0.25 meter, length of lower arm is given 0.25 meter, pivot distance of the upper arm is given 0.4 meter, pivot distance of the lower arm is given 0.5 meter, and the friction is given as 20 Newton. So for this problem we should mention all the values. First we should find h and tan alpha, next tan beta. These are the steps to find the values. So n minimum becomes 191.0368 rpm. Next, for maximum speed condition, find n max. N max value is 211.538 rpm. The range of speed is the difference between maximum and minimum speed. After finding these two values, the difference is 211 minus 191 is 20.50 rpm. Similarly, for this problem, the values are given. Substitute the values. Tan alpha is this value, beta is this value. Find q, and for n minimum we get 176.078, and n max we get 187.968. Therefore the difference will be next. In this problem, length of each arm is given, mass is given. We are asked to find the same specifications. Finding maximum speed including friction and minimum speed, and the difference between the two values. So this is a Proel governor in which we have the extension of the lower link. The extension of lower link is given. So this is the formula to find the range of speed of the governor for Proel governor. Take the given values, substitute the values, find n1 and n2. For finding n1 and n2, we should know the values bm, hm, mn, capital M. After finding these values, find the range of speed. So this is a type of Proel governor. So this is a Hartnell governor in which mass is given, length is given, values of minimum equilibrium speed, maximum equilibrium speed is given. Draw this diagram. So this is a problem for Hartnell governor. The speed range is given, lift is given, sleeve arm is given, ball arm is given. Find the radius of rotation when the arm is vertical and speed of the governor. Thank you.